All right, guys. So today we're going to start chapter 5, which is all about polynomial functions and stuff, which we've already kind of dealt with a little bit. Last unit was all about quadratic functions. All right, so specifically polynomial functions that are second degree. But now we'll look at what happens if we have like a third degree or a fifth degree or a fourth degree, stuff like that. Okay, so a lot of the same stuff we did last unit, just building on that and going past kind of what we looked at there. So lots of graphing calculator kind of stuff. Today deals with kind of just some general knowledge type stuff about graphs of polynomial functions, some quadratic, some higher degree or lower degree. It's kind of all over the place here. Let's see, from just getting it done kind of standpoint, we'll probably have just a few less kind of Q&A kind of days, work days, so you may have to increase slightly what you do outside of class. We'll just see how it goes on that, though. Let's go ahead and get to it then, talking about 5.1 polynomial functions. So basically, after this, you want to kind of be confident in doing 3 things, right? So you want to be able to classify, you want to be able to graph, and you want to be able to describe the ending behavior and really some other things about polynomial functions. Okay, so let's see our fill in the blank part. A polynomial is a function that consists of the sum of many terms, and it's one of the most important parts about it. It's degree, D-E-G-R-E-E. That's the value of the highest exponent. So again, last unit, tie in what we just did. We dealt with pretty much specifically second degree polynomial functions, right, which are called quadratics. The polynomial function in standard form must have terms arranged in descending. It says descending numerical order. That's referring to the degree. All right, so you might just want to say that means the degree. Okay, and then it gives you this fancy, formula that nobody knows what it means. Basically, all that's saying is that you just go, highest degree to lowest. Many times the lowest is a 0 degree term, which is a constant term, right? It doesn't have that variable on it. All right, so we will go ahead and get into the naming part, right? That's part of our learning target. So we basically name by degree and then number of terms, okay? So let's go ahead and fill out this chart. If something is 0 degree, then that's called a constant term. Okay, so like 5 is 0 degree, okay? First degree is called linear. So 5x would be a linear term, right? Second degree is quadratic. 5x squared would be quadratic, right? Third degree is, anybody know what that's called? Starts with a C. No, cubic is the word there, cubic. So 5x to the third, right? See how that goes. What about fourth degree? Anybody know what that would be called or have a guess? It's not a real common word. Nope. Trying to give you guys a chance to show off here. Quartic. And then the last one, fifth degree, would be called quintic. And I may be wrong about this, but I think that is where the special names end, right? You just name them by their number after that. So like 6th degree would just be called 6th degree, no special name. All right, so what if we have a polynomial with 0 terms? That's nothing, right? So that doesn't have a name. Polynomial with 1 term is called a monomial. Second degree, anybody know? Starts with a B. Binomial. Third degree, trinomial. Good. And then that's where the special names end. Okay, so after that, they're just polynomial. We just use the generic term polynomial. All right, so you can reference this chart. Hopefully, you can kind of start to memorize these names as you go, so you don't have to cross-reference the chart every time. All right, so we have two jobs in these problems. We want to write them in standard form and then classify them. So in terms of order, our fourth degree term is going to be written first, third degree second, and first degree last. Okay, so standard form would be 5x to the 4 plus 3x to the 3 minus 1x. That's in standard form. Okay, now we can classify it. So we would, by degree, it's fourth degree. So that is called quintic. No, quartic. Quartic. And then number of terms, there are 3. So that's called a trinomial. This is a quartic trinomial. You don't really need to capitalize those. I'm not sure why I did that. But, and then looking at B, what would we do with the order of those terms there? How would we simplify that expression, x squared minus 4x squared? Any thoughts? This is a little bit of a curveball, but yes? Yeah, you wouldn't really move them, but what would we do? We can simplify. If I just told you to simplify this, what would you do? Right, yeah, just combine like terms, right? So 1 minus 4 to get negative 3 x squared. So this looks like a binomial. It's actually a monomial when we simplify. So negative 3x squared. Now it's in standard form. And then, if you ever have one term, it's automatically in standard form. So this would be called a quadratic based on the exponent. And then a monomial because there's only one term. Somebody's doing some fun stuff out there. All right, you guys try C and D. Feel free to work with each other. If that helps, you can reference the chart. Try to do what you can, maybe without that, okay? We'll go over them in about a minute and a half. So standard form first, and then by degree, and then by number of terms. Looks like people are getting done a little early, so I'll go ahead and start to write them up. All right, so looking at C in standard form, once we combine like terms, we really have two terms, and it's called linear because it's first degree. So linear binomial. And then D is just rearranging them. Still has four terms, fourth degree, so it's called a quartic polynomial. Anybody have any questions about that? All right. So not a whole lot of math involved there, but knowing how to write in standard form is important. Now we'll kind of get into describing these graphs. So some key features that we'll focus on that have to do with the degree of the polynomial. So the degree affects the shape of the graph, the turning points, and the end behavior. The places where the graph changes direction, those are your turning points. So think about what we called the turning point on our functions last chapter. We called that the vertex, right? So when you think turning points, you think vertex, where we get that change in direction. The directions of the graph to the far left and the far right are called the crazy people. Just kidding. That was a political joke. It was a reach. I'm sorry. But those are called the end behavior. Okay, end behavior. All right. So here's how it goes. In this chart, I don't really find it super helpful. You might, so we'll go over it. I'll tell you how I think of it to maybe simplify it, okay? So you'll be asked, in these next questions, what's the end behavior? Kind of without a graph, can you tell me what the end behavior is? So what's all this mean? So even and odd are referring to the degree, okay? So these are the degree, just so we know what we're reading here. And then positive and negative is like the lead coefficient, okay? So what we called A last chapter, okay? So these right here are the lead coefficient. All right, so let's focus on those even degree polynomials. So second degree, fourth degree, 80th degree, right? They're all going to behave the same way at the ends, okay? And so if A is positive, if your lead coefficient is positive, it finishes, it starts facing up and ends facing up. So up and up. And again, our most famous example, if you want to draw a picture, is just an upward-facing parabola.
Please pardon this interruption. At this time, all those with permission to attend the Ivy Tech field trip are dismissed. Please go to door 1, where you will catch your bus. At this time, all those with permission to attend the Ivy Tech field trip are dismissed. Please go up to the rotunda to get your bus.
That's just one of those good words, rotunda. It's a cool word. Negative, if it's even, it's going to be down and then down again. All right, so again, a famous example, a downward-facing parabola. Okay, and again, that's how I think of it, right? If I see a 6-degree polynomial, I'm going to treat it just like I would a parabola, right? It's going to look different, but it's going to have the same end behavior, right? Just so you know, okay? If it's 6th degree, I wouldn't write all this out, but if it's 6th degree, it's going to look maybe in this situation, if the lead coefficient is negative, it's gonna start facing down. They can have 1, 2, 3, 4. Wait, 1, 2, 3. Yeah, and then 4, and then 5, right? So it could look more like that, right? But it's still down and down. Do you guys see what I mean by down and down there? Does that kind of make sense? Pointing down on both ends. So what about the odd ones, right? So they are going to be they're going to have one. They're not going to match at the ends, right? It's either going to be up and down or down and up. Okay. So if your lead coefficient is positive, I think about a positive slope line, right? That's as simple as you could make it because that's first degree, right? So that's going to be start down, start pointing down, and then end pointing up. Okay, again, the most simple example is a positive slope line. That's first degree. So, you know, something like that, right? Down and then up. And then a negative slope line would start pointing up and then end pointing down. So up and down. Something like that, right? And again, so you know, one other odd one you might have seen before is a third degree. So let's say it's a third degree with a positive lead coefficient. It's going to look more. It's not going to be linear. It's going to look more. It could look more like this. So something like that, right? So again, doesn't look like a line, but it's still down and then up, right? Does that kind of make sense? And if it doesn't make sense, you know, what other approach could I take to answer these questions other than the chart? Look at your graphing calculator, right? You do have to be careful and make sure maybe you zoom out a bit to make sure you're seeing the whole function, but you could just look at your graphing calculator, right? Let's try without, but again, if it's on a test, you could definitely reference your graphing calculator. So what is the end behavior? Okay, so here's what we look at. We look at it's odd. So if we're looking at the chart we just filled out, we're thinking about a linear graph, and then our lead coefficient is positive. So again, to me, I think positive slope line. I can picture that in my brain. I don't need to look at the chart. I know that's down and then up. Some people's brains don't think like mine, right? So what else could you do on that one, right? It says without your graphing calculator, but again, if it's a test question, you could just look at it, right? So if we just punched it in real quick, sorry, that's to the third. Let's try that again. So 4x, and then to the third would be caret 3 minus 8x. Then if we look at the graph, you can kind of see down and then up, right? So that's really as difficult as these are, okay? But if you can understand it without the graphing calculator, I guess that's a little better. So anyways, next one is even degree. So we're thinking parabola. This one actually is a parabola where A is negative. So that's either up and up or down and down. Which one would this be? Any thoughts? Somebody knows. We just did a whole chapter on these. Down and down. All right. You guys go ahead and try to name that end behavior. I'm going to kind of give you a little less time, see if you can go quicker than maybe just punching it in on your calculator, and then we'll talk about them. So in about 30 seconds or so. So blank and blank. You're just talking about that end behavior. Ava B, you just look like you're having party time today. You're an efficient napper, you know. It's like if I can squeeze in a 20-second nap, I'm gonna do it. All right. Anybody want to volunteer for C? What would you think on that one? Did you know it? Did you understand it? Anybody want to take a stab at it? Nobody. All right. Well, it'd be the same as B, right? It'd be the same as graph B, right? So we see an even. So think parabola, or look at the chart, or look at your graph, and then it's got a negative lead coefficient. So that'd be like a down-facing parabola, down and down. Okay, what's kind of the curveball they gave us on example D? Not too bad of a curveball, but what is it? What'd they do different? Yeah. Right, it's leading is not in the front, or it's not in standard form, right? So you didn't need to look at the 1, you needed to look at the 3x cubed, right? So we're looking at a positive lead coefficient and a negative degree. So it is going to be either up and down or down and up. Which one would this be? Anybody know? Did you get one of those? Up and down and up? Yes, down and up. Just like a positive slope line. Down and then up. Okay. Anyways, we'll go ahead and move on to the last part. Okay. So the last part's where we kind of put it all together. We graph and then we talk about key features. So we had a lot of questions like this, similar to this, on the 4-1 test, where you had to graph the parabola and name key features. These are just going to be different key features, right? So you might start by just punching it in. Okay, that's how we'll start. And if the up and down stuff didn't make sense last time, maybe it will here. We can just look at the graph. So we got 2x to the third. Remember, to the third, there is no x cubed button. You have to hit the caret key and then a 3. And then you have to arrow out, okay, before you type the next term. So then minus 3x squared minus 1. And then I'm just going to look at the graph and see what I can see. All right. So it looks like, what would the end behavior be based on what you see on my calculator there? What would we say? Somebody. I'm going to wait until somebody says it. How about that? We're on video too. I'll make this awkward. What is it? Down and up. That's right. That's right. You guys are a tough crowd. Tough crowd. All right. Down and up. That's right. And turning points. So here we are going to name specific turning points on the graph, right? So we're thinking vertices here. Visually, it looks like it turns at maybe 0, -1, and maybe 1, -2. I would probably want to confirm those from the table, that those are on my graph. And we see, okay, okay, so it actually doesn't turn there. Does it? So 0, -1, and then what else did I say? Okay, did I type it in wrong? I must have typed it in wrong. What did I type wrong? I do have it in wrong. What's the function say? 2x cubed. Okay, thank you. Let's try again. Sorry about that. So still down and up. All right, so yeah, thank you guys for helping me out there. So yeah, it looks like 0, -1, and 1, -2. So let's go ahead and name those. You gotta be careful when you type them in, obviously. Ultimately, we are going to graph this, so let's go ahead and plot those 2 points. Okay, that'll be 2 of like what I call our guide points. And let's go ahead and just finish with our graph, and then we'll go from there. So beyond those 2 points, I would just say from your table, anything that would fit on your graph, include it, right? So -1, -6 would work. So we'll put that on there. So like right there. And then there's one more, because -2, -29's off, but 2, 3 would work as well. So that way we're being real accurate. Now we'll just trace through them as best we can. I wouldn't go real far past your guide points, right? Just make an arrow to extend it, okay? And it doesn't have to be perfect. It does need to go through those points, though. All right, so now let's name intervals. This part could be a little bit tricky, so just try to follow along. Basically, we have three different intervals. If you have 2 turning points, there are 3 intervals, right? 2 of the 3 intervals are increasing, right? So it increases from here to here, right? And then also from here to here, okay? So how do we name those? We name those by thinking about the x values where it's increasing, okay? Now, you can see where that's a little bit confusing because we say, on the left side it's pointing down. How's that increasing? Well, when we read from left to right, it's going up, right? Positive slope line. Anyways, it's increasing from -infinity up to where x is 0. From negative infinity to 0, it increases, right? Then it takes a short decreasing break and increases again from where x is 1 to infinity. Sorry, they're never or equal to on these, so just... All right, and then it decreases, you know, from here to here, right? That's just from 0 to 1. So that might take some work, just naming those intervals, but we will work on it, okay? Any questions before you try one? All right, you guys go ahead and try one. Try to do the whole thing or as much as you can, and I'll go over it. While you're working, I'm going to go ahead and post the homework. If you know you have it all, you can go ahead and get started. I will give you guys kind of a work day on Tuesday before break next week. We got us a break coming up. That's exciting. So keep that in mind too. And if you don't get something, lean on your partner, right? They'll help you. You don't know how to punch in third power, that's where your partner can help. Ask me if you don't want to ask your partner. All right, so I'm going to go ahead and started to fill some of this out. Turning points and then up and down are up there on the screen. I'm going to finish with any other points I can fit on my table or on my graph, which would be -2 goes to 2 and 1 goes. Sorry, -2 goes to 2 and 2 goes to -2. Okay, so again, just those points aren't going to be helpful, but if we think about the picture, we know kind of the shape of it. Which is going to be like that. Okay, and then the intervals, that's probably going to be the toughest part. There's only one increasing interval, and it's from here to here, right? And so that's from where x is -1 to where x is +1. All right, and then my other two are called decreasing intervals. Okay, so from negative infinity up to -1. And then also from +1 to positive infinity. Well, go from 1 to infinity. So what do we have questions about after you tried one and then you get a little feedback? Anybody have anything? Or okay, well, that's what I thought you might say. But anyways, there you go. If you look at the filled out notes, I think there's quite a few mistakes on this last part. I'm going to repost those later, but hopefully this helps. The homework's posted. And that's a wrap.